Hello everyone, welcome back to my channel. In this video we are going to discuss about the transmission media. The transmission media are the physical infrastructure, and these physical infrastructure carry the data from one computer to another computer. So this is the physical medium through which we can carry the signal between the sender and receiver. The example is if we are using any light bulb or any ceiling fan, assume that there are wires which actually carries the electric current from switch to fan. So this electric wires are nothing but a transmission media which is transmitting the electric current from switch to fan or light bulb. Similarly, the transmission media also play the same role in the data communication and networking to transmit the data from one computer to another computer. So these physical infrastructures or the components which actually carries the data from one computer to another computer. Let us assume that there are two friends who are talking with each other. Now one is saying that how are you Shrikant, another one is saying I am fine. So this is how the conversation took place between the two friends or in two peoples. So similarly in between these two peoples there is a air is playing a transmission media role. So air becomes a media in between these two friends. So with the help of air they are communicating with each other. Similarly in computer also we require the transmission media, and this transmission media in data communication is broadly classified into two main categories. One is called as guided media, another one is called as unguided media. Further, in the guided media, we have twisted pair cables or wires, coaxial cables, and optic fibers. Similarly, in wireless media also, there is radio waves, microwaves, and infrared waves. If we talk about the guided media, as we know that it is further classified or divided into three main types as we shown in the figure. So twisted pair, coaxial cable, and optic fibers. And actually these twisted pair and coaxial cables carry the signal in the form of electrical current, whereas the optical fiber carries the signal in the form of light. Let us understand one by one. Twisted pair cables. These twisted pair cables consist of two copper wires which is twisted like a DNA helical structure, so that you can find it in the image. We have mentioned how these two wires are twisted with each other, and both the copper wires are insulated with the plastic covers, and there are usually a number of such pairs or combinations together and covers with a protective outer wrapping. So this is the outer wrapping. You can see my mouse pointer. This is the outer wrapping. So in this twisted pair there are two further classifications we can say, or two classes of twisted pair cables we can have. Unshielded twisted pair cable, that is UTP, shielded twisted pair cable, that is STP. You can see there is a only difference between this UTP and STP is this metal shield. STP has this metal shield, whereas this UTP doesn't have metal shield. Now understand UTP, actually it is the most commonly used medium today. It uses in the telephone systems, this UTP, and it can carry both voice as well as the data. And If we talk about STP cables, so STP is, as I said, that it is metal shield protected. So metal shield prevents the penetration of the electromagnetic noise. So it also helps us to eliminate the crosstalks. Crosstalk means somebody others. If we are talking with our friend, we cannot get the other's voice. The other's voice will not be indulged into our conversation. So that crosstalk will not be there in the STP. So therefore we say that STP helps to eliminate the crosstalk. Coming to this coaxial cable, this is also called cox. Coaxial cable is also called as cox. And when we see this figure, see there is a center conductor. So that is a copper core, and thereafter there is a dielectric, that is insulating material. Thereafter we have a foiled shield and braided shield. Shield is also called as outer conductor, and after that there is a outer jacket, that is for protective purpose. So that is protective plastic coating or PVC. So this coaxial cable is having more capacity than the twisted pair cables. So coaxial cables are divided into various categories depending upon the thickness and the size and the shield and its insulators and outer coating, and considering the other things of the coaxial cable. So therefore there are different types of cables are used to carry the higher frequency for the longer distances. So in the coaxial cables we can find RG8, RG9 and RG11 and RG58 and RG59 coaxial cables. So these can be used for the higher frequencies and for the longer distances. The third guided media is the optical fiber. So this optical fiber use the light instead of electrical signal. So coaxial use the electrical signals, twisted pair cables use the electrical signals, whereas the optical fiber uses the light instead of the electrical signal. That is mean of signal propagation. So therefore these OFCs are made of glass fibers and that are also closed with the PVC or Teflon, right? So there is a thin transparent strand of glass at the center is covered with a layer of less dense glass called cladding. So this is the core. This is the core, that is the actual fiber, and thereafter this is the strength member buffer, and there is a outer jacket that is made up of plastic or PVC or Teflon. Such type of cables, means the OFC cables, are used as a backbone for the network. So it's a expensive one compared to the previous two. It is very much expensive, and also these cables are lightweight and have a higher bandwidth compared to the coaxial and twisted pair cables. And also these optical fiber use the reflection to guide the light through the optical fiber. A glass or a plastic cover is surrounded by a cover of a less dense glass or plastic, so signal can travel for a longer distances and electromagnetic noise cannot affect these cables. So that is the advantage of this OFC. We say that the light travels at the speed of 3 lakh kilometers a second in these OFCs. So therefore we can get more faster signals or more faster data transmission in these OFCs compared to the previous two. So to achieve the full duplex, we require the two cables. However, if you are using one optical fiber cable, it is always a unidirectional one. So we can achieve only one directional signals. So that is your unidirectional signals. So the main advantages of these optical fiber cables are these are resistance to noise. Noise will not be added to the signals, and it has a huge bandwidth, and we can carry the higher signals, means we can carry the higher signals for the longer distance. Sorry. So these are the most beneficial part of the optical fiber cables, but there are some disadvantages like maintenance cost might be higher side compared to the previous two, twisted pair and coaxial, and overheads cost are more. The cost of the fiber cable is expensive compared to coaxial and twisted pair cables, and it is very fragility means more delicate than the twisted pair and coaxial cable. So these are the some of the disadvantages of the optical fiber cable. So coming to this wireless transmission media, the range of the wireless transmission media is 3 kilohertz to 900 terahertz. This is the actually the entire frequency, or we can say the spectrum of the frequency of the wireless transmission media. So as you can see in the first paragraph, we have said that the information travel in the form of magnetic signals through air. So we are passing all the electromagnetic signals through the air, and for that we are using the spectrum of the frequency from 300 kilohertz to 900 terahertz. So this is the range which we have for the wireless communication purpose, and the two or more devices are allowed to communicate via this wireless transmission for short distance, for longer distance, and without requiring any physical connection. So therefore it is called unguided media. The wireless communication is also called as unguided media because there is no physical connection is required. Without physical connection, the two devices can communicate with each other. So the signal propagate through the air, means whatever the signal we are passing, that is through the air, and also sometimes water. Now there are many types of wireless communication technologies are available, such as Bluetooth, Wi-Fi, WiMAX, etc. So Bluetooth, Wi-Fi, we are nowadays we are all using in our smartphones. We are using Bluetooth also, Wi-Fi also, and electromagnetic spectrum, that is the range, and this range is categorized into 4 types. So we can find the 4 types, and those 4 types are radio waves, microwaves, infrared waves, and light waves. Now you can see this figure. Okay. Okay. So coming to this infrared. Okay. So the most common example of this infrared waves are our remote. As you can see in the figure also, there is a remote, there is a television. So if we operate means if we are using the remote, it is mean by we are operating the infrared waves. With the help of infrared waves, we can able to change the channels. So this is how we can use this infrared radiation to change the channels or to increase or decrease the volume of the television, and also some of the functionalities we can operate. Whatever the functionalities available in the remote, we can operate, so with the help of this infrared radiation. So this is the first waves, right? So this is the infrared is the first one, and in it is used for the short range communication, like for TV remotes, mobile phones, personal computers, etc. Even in science, the infrared is the part of the spectrum that is not visible to the human eye. If you take your remote at your home, and if you press the button of the remote, you will be getting the LED light will blink, but you won't see the radiation, you won't see the spectrum of the infrared. Okay, the limitation of this infrared rays is they cannot penetrate any obstacles. Obstacles means they cannot penetrate, means if you are in one room, your television in another room, if you operate the remote from your place, it won't operatable, or it cannot bend this radiation, so it cannot cross the walls. So that is one obstacle, or we can say the limitations which we have in this infrared. And also infrared is used in a night vision cameras. So these infrared are used in night vision camera, and it has a thermal property, and you can see the frequency is also given, and we have seen this frequency in this figure also, 300 gigahertz to 400 terahertz. So this is the range of the infrared. There are certain advantages we have. That is one of the secure wireless communication media because of the short range, and also other wireless media. Infrared is quite inexpensive. Inexpensive means the cost is very less compared to the other wireless media. So this is the advantage, whereas the disadvantage is it is only used for short range, and the signals cannot penetrate any obstacles like walls or any building. So that is the disadvantage of this infrared waves. Okay, so coming to this radio waves. So radio waves, it does not have a limitations like infrared waves. That is the first advantage of the radio waves. It can travel a large distance, and also can penetrate any wall. So these waves can move in all the directions. So that is the advantage of this radio waves. And also the requirement of the radio wave is only the antennas are required to access these radio waves. 15-20 years back or 20-25 years back, we were using the antennas for our television. So DD National was there, and if we are having television, we were having the antennas on our rooftop, so that the antenna catch the radio wave signal, and we can watch the DD National channel. So that was the situation 15, 20, 25 years back. So we were using antennas. Even for the radios also, we were using the antennas. And these antennas, there is a sending antenna where one can transmit its message, and other is the receiving antenna. Means a single antenna cannot perform both the task. Only one task can be performed by one antenna. So if I am using one antenna, means either I can send or I can receive only. I cannot do both the task through one antenna. And also there is a frequency which starts from 3 kilohertz to up to 1 gigahertz. In this 3 kilohertz also there is a classification in the radio frequency, and there is radio waves of frequency 300 kilohertz to 30 megahertz can travel a long distance. If I am using 300 kilohertz to 30 megahertz of radio frequency, so these frequency can travel for a longer distance. Even though if you find there is a figure, I have mentioned it. So you can see there is a receiving antenna and there is a transmitting antenna, and there is a transmitter is there. That transmitter is connected with the antenna to transmit the signals, and at the receiver side you can see there is a connection between the receiver device and the receiving antenna. So this is how the transmission taken place between the two devices in the radio waves. So there is a frequency of the radio waves which is range from 3 kilohertz to 1 gigahertz, and it is further classified in the radio waves for the radio communication like VLF, that is from 3 kilohertz to 30 kilohertz, and 30 kilohertz to 300 kilohertz there is a low frequency, and this low frequency is used for a long range radio navigation or navigation locators. And there is a middle frequency. The range of the middle frequency is 300 kilohertz to 3 megahertz, and in these middle frequencies are used for AM radio and radio direction finding and emergency frequencies. Similarly, the high frequency, that is 3 megahertz to 30 megahertz is used for high frequency. So these frequencies are used for international broadcasting, military communication, and even though for telephones also these were used high frequency, that is 3 megahertz to 30 megahertz telephone and facsimile communications. So these high frequencies are used. And after the high frequency, from 30 to 300 megahertz is used for very high frequency, right? So this very high frequency is used for the FM radio and aircraft AM radios, and even though for the aircraft navigations also this very high frequencies were used. And after a very high frequency there is a ultra high frequency, and ultra high frequency starts from 300 megahertz to till 3 gigahertz, and these waves are used for television purpose, for our mobile purpose, and for microwave links purpose. And after the ultra high frequency there is a super high frequency. So I will come to advantage, disadvantage. So super high frequency, so in the super high frequency these are used for satellite microwaves and for the radar communications. And finally the 30 gigahertz to 300 gigahertz, that is the last frequency of the radio communication, 300 gigahertz. So 300 gigahertz up to 300 gigahertz, from 30 gigahertz to 300 is used for extremely high frequency, and these extremely high frequency waves are used for the space and also for the scientific application. Even though for the satellite communications, for the radars also these extremely high frequencies are used. So this is how these radio waves are used. The main advantages of using these radio waves are we can travel, means the data can travel for the longer distances, and it can cover all kinds of direction, omnidirection we can access the data. So it can pass through any obstacles. So there is a wall or there is any other obstacles are there, so it can cross any obstacle. So this is the main advantage. The second one is, since this radio waves are the wireless communication media, there is no need of any kind of digging and putting a wire and spreading the wire across all the cities and all is not required, right? So that is also the second advantage. There is a disadvantage of radio waves, is that these are not effective in bad weather condition. Our weather is bad, so we might get some obstacles, we might not get a proper communication, or data cannot be properly sent or received. We might get some of the problems because of bad weather conditions. Okay, so therefore we say that so in the bad weather condition, these radio waves are less secure, as they can travel for the larger distances. Okay, so the third one is the most important, is the microwaves. The microwaves use a line of sight method of propagation. The meaning is both the antennas, the sending and the receiving, should be properly aligned. Okay, let me show you. Okay, this kind of figure means this kind of straight line of communication is required in the microwaves. So what happens in the microwaves? Always there is a sending antenna and receiving antenna should be properly aligned. The distance covered by the signal is direct proportional to the height of the antenna. The two antennas must be in the straight line, the sending and the receiving. That is the first and foremost point we have to remember in the microwaves. And also the microwave signals range between 1 gigahertz to 300 gigahertz. So already we have studied so 300 gigahertz. So 300 gigahertz means up to 300 gigahertz we can get the extremely high frequency, and these extremely high frequencies are used for the scientific application, for the space, for controlling the satellites and radars. And these microwaves are used for the mobile phone communication, also for the television distribution also. There is an advantage of the microwaves are, these are very fast way of communication, and they can carry 25,000 voice channels at a time. So the second one is, as it is a wireless communication media, so that again there is no digging, putting the wires and spreading across all the cities is not required. So this is the second advantage. There is a disadvantage of microwaves, is the cost of the microwaves are bit high. So these are very expensive, and even though installation and maintenance is also difficult, hence it is very expensive. Because of it is very expensive, so microwave is also not very effective in bad weather conditions. So this is also the disadvantage of the microwave. Coming to the fourth one, that is the light transmission. So in the light transmission, in the modern application, this light transmission is used. And if you have the modern application to connect the two LANs of the two buildings via the laser mounted on their foot tops, as you can see in the figure. So each building needs its own laser. So we have already mentioned here. Okay, so there is a laser in this building also, in this building also. Okay, and also each building is having the photo detector, right? So photo detector will detect the laser signals, and these laser signals strength is very narrow, and we can achieve the higher bandwidth in the lower cost by installing this laser and photo detector, and it should be in a straight line for transmission of the light transmission. Okay. So the main disadvantage is these laser beams cannot penetrate the rain or thick fog, but they normally work well on the sunny days. This is only one advantage. On sunny days, means there is no bad weather, then only these can work fine. If the weather is bad, raining or thick fog is there, so the beam cannot penetrate this rain and thick fog. That is the disadvantage of the light transmission. In the wireless communication, we have the wireless technologies like Bluetooth. Bluetooth is the wireless technology, and this Bluetooth is used for the shorter range wireless technology, and this can be used to connect the mobile phones, mouse, headphones, keyboards, computer devices, and other peripherals. And the limit, or we can say that the range is only the 10 meter. Within the 10 meter we can access all these connected Bluetooth, and we can reach up to 1 to 2 mbps of speed in the Bluetooth. And the range which we have, that is 10 meter, that builds a personal area network, and that personal area network is called as piconet. So piconet is nothing but a personal area network. That range is 10 meters only. So there will be a master device which can communicate up to 7 active slaves. So active slaves means I can connect 255. See, I have mentioned it. Bluetooth technology allows up to 255 devices to build a network. So we can build a network by connecting 255 devices. But at a time, or we can say at the same time, we can access 7 slaves. One master device will be there. If I am connecting with my smartphone becomes a master device. I can connect 7 active slaves at a time, but I can have 255 devices. I can allow it. I can connect 255 devices, but I cannot access all 255 at a time. I can access only 7 slaves at a time. So therefore we have said that 8 devices can communicate at the same time. Why I am saying 8? Because one would be the master device. Okay, this one would be the master device, 7 would be the active slave. So 1 plus 7 becomes the 8 device can communicate at the same time, and the remaining device can enact waiting for a respond command from the master slave. So you can see in this figure, so these are the slaves, this is the master, laptop is the master. So these can be connected through this master. So up to 7 I can connect, 7 slaves I can connect. So one can disconnect and other can be connected. In this way I can communicate with 255 devices. There is a wireless LAN in the wireless technology. So I can have the wireless LAN, so I can get connected with the other devices, right? So that is called VLAN, or wireless local area network. So it is a popular way to communicate to the internet. So if you have the router, so you can access other devices at your home, like Alexa. If you have mobile phones at your home, you can have one wireless access point, so that everybody can connect with wireless access device and they can access the internet. So this wireless LAN numbered as 802.11, and it is popularly known as Wi-Fi. So Wi-Fi is also a wireless technology. So this is all about the wireless communications transmission medias. So there is a benefit of the wireless LAN is it can connect and extend the replace and existing wire infrastructure. Means we cannot have any wire communication, we can connect with the wirelessly, so we can replace easily. So these are the some of the benefits which we have of the wireless technology. I hope that you understood this transmission media. So if you have not subscribed my channel, so kindly subscribe my channel, like and share. So thank you very much for the video. Thank you very much for watching.